Hey everyone, and welcome! Today we're going to dive deep into the major landforms of our planet. We'll break down all the key concepts from the NCERT chapter to really understand the mountains, plateaus, and plains that make our world so interesting. So, have you ever just looked at a globe and thought, why? Right? Why isn't the Earth just one big smooth ball? The surface of our planet has this incredible variety of landforms. Some are super rugged and tall, others are incredibly flat. And believe me, it is not by accident. And just look at this. You've got it all in one view. Majestic mountain ranges, vast plateaus, and these huge, sprawling plains. All these diverse landscapes are basically the result of a constant tug of war between two really powerful forces. So let's break down what those are. To really get how landforms are made, we first have to meet the Earth's two master sculptors, what we call the internal and the external processes. So, on one hand, you've got the internal process. This is movement deep within the Earth that's constantly pushing the surface up or causing it to sink. It's kind of like the builder. But then you have the external process, which is always at work wearing down and rebuilding that surface. Think of forces like wind, water, and ice. They're constantly eroding the land and then depositing that material somewhere else. It's this nonstop cycle of building up and tearing down. So, with that in mind, let's kick off our journey at the very top with the most dramatic of all landforms, the mighty mountains. Okay, so what is a mountain officially? Well, it's a natural elevation that has a small summit, a broad base, and it has to stand over 600 meters higher than the area around it. You know, some are so incredibly high they actually reach above the clouds, becoming home to these permanently frozen rivers of ice we call glaciers. Now, not all mountains are created equal. They actually form in different ways, and we can group them into three main types. You've got fold mountains, block mountains, and volcanic mountains. So let's break them down one by one. This is such a great way to think about a pretty complex idea. Just imagine the Earth's crust is like this sheet of paper. Now, if you push it from both sides, what happens? It buckles and folds upwards, right? It creates these little peaks. That is exactly how fold mountains are formed. And the result of that process, you get these majestic ranges like the Himalayas and the Alps. These are classic examples of young fold mountains, which is why their peaks are so rugged and high. Now, on the flip side, ranges like the Aravallis in India are super old fold mountains, and they've been worn down by millions of years of erosion. Next up, we have block mountains. These are created when huge areas of the Earth's crust literally break and shift vertically. The blocks that get pushed up are called horsts, and the blocks that drop down are known as grabens. A perfect real-world example is the Rhine Valley in Europe. It's a graben sitting right between two horsts. And finally, we have volcanic mountains. As you can probably guess from the name, these are formed by volcanic activity. Molten rock or magma forces its way to the surface, and it erupts as lava and ash. Over a long time, these layers just build on top of each other, forming that classic cone-shaped mountain. Mount Kilimanjaro in Africa and Mount Fujiyama in Japan are two really famous examples. Okay, get ready for this, because it's a mind-blowing fact. We all know Mount Everest is the highest mountain above sea level, right? But the tallest mountain from its base all the way to its peak is actually Mauna Kea in Hawaii. Most of its massive 10,205-meter height is totally hidden underneath the Pacific Ocean. Crazy, right? But hey, besides being amazing to look at, why do mountains actually matter so much? Well, they're absolutely vital. They're storehouses of water because their glaciers feed many of our biggest rivers, and that water is then used for everything from farming to generating hydroelectricity. Plus, they're home to a rich variety of plants and animals and are fantastic hubs for tourism and sports. All right, coming down a bit from those towering peaks, our next landform is the vast, elevated tabletop of our planet, the plateau. So a plateau is basically an elevated tableland. It stands high above the area around it, but the key difference from a mountain is that it has a large, flat top. This picture just nails it, doesn't it? You can clearly see those steep sides and that flat surface. Plateaus can be anywhere from a few hundred meters high to several thousand. The Deccan Plateau in India, for example, is one of the oldest in the world. Now, this is where plateaus get really useful. They are absolute treasure chests of minerals. The African plateau is famous for its gold and diamond mines, while right here in India, the Chota Nagpur Plateau has huge reserves of iron, coal, and manganese. It's no surprise that so many of the world's mining areas are located on plateaus.
And that brings us to our final major landform, the one that has been the foundation for so much of human civilization, the plains.
Plains are just these huge stretches of flat or gently rolling land, usually not more than 200 meters above sea level. Most of them are formed by rivers. As rivers flow down from the mountains, they act like conveyor belts, carrying all this eroded material with them. When the river slows down on flatter ground, it just drops its load of sand and silt, building up the plain, layer by layer, over thousands and thousands of years. And what's the result of all those river deposits? Well, you get this incredibly fertile soil. And that right there is what makes plains the most productive areas for farming in the entire world. They're just perfect for cultivation. So why is that such a big deal? Well, it's a perfect combination. You've got fertile soil for growing food, and you've got flat land that makes it super easy to build houses and transport networks. This all means plains are the most useful areas for people to live. It's why they are the most densely populated regions on Earth, and it's why so many great civilizations, like those on the Indo-Gangetic Plains, flourished there. All right, we've covered a ton of ground. Literally. So let's put it all together with a quick comparison. This is perfect for locking these ideas in, especially if you're studying for your exams. This table really sums it up beautifully. Let's just run through it. For elevation, mountains are high and steep, plateaus are high but flat on top, and plains are low and flat. Simple. For their main use, think of mountains for water and tourism, plateaus for mining minerals, and plains for farming and living. And of course, this directly affects population. Mountains are sparse, plains are super dense, and plateaus are somewhere in the middle. So, to wrap it all up, if you remember nothing else, remember these 3 crucial points. Number 1, landforms are shaped by that constant push and pull between internal forces building up and external forces wearing down. 2, mountains, plateaus, and plains are all totally distinct, with their own ways of forming and their own unique uses. And 3, the type of landform directly shapes where we live and what we do. It's as simple as that. So, if this explainer helped you get a better grip on Earth's major landforms, please hit that like button, share it with a friend, and subscribe for more content. It really does help the channel a lot. Thanks so much for watching.